The question was, do you have to color your dot to dot? I would like for you to color it, but if nothing else, you can just get a marker and you can outline it. I'm okay with that too. All right, like I said, we're gonna get started. So for today's notes, it is solving systems of linear equations and linear inequalities. And we're doing it by graphing. So there's a couple of things that happen. When you graph systems of equations, you get one of three situations when you're dealing with linear inequalities and equations. So one situation is that you have two lines and you graph them. And when you graph them, so that's one situation. You got two lines, you graph them, and what happens is you get one time they cross each other, that is one solution. Another situation that can happen is that you have two lines and you go to graph them. And we'll pretend like those are really nice straight lines. And it turns out that there's no solution because they are never going to cross. So in the first box, we can also, well, we'll come back to it. The other thing that happens is that sometimes you go to graph a line, and this is harder to draw, and then you go to graph the other line. And what you find out is they're actually the same exact line, and that is an answer. There is an answer for that. That means that there is infinitely many solutions. Okay, so there's infinitely many solutions. And the reason that these things happen, so the reason that you don't get a solution for the middle one is because you have the same slope. And when you have the same slope, it means your lines are parallel. And they never cross, they never intersect. For the first column, you have different slopes, you have different lines. And when you have different lines, you get an intersection. Okay, when you have different lines, they're going to intersect. At some point, they're going to intersect. It might not intersect in the picture that you have, but they're going to intersect. In the last situation, they are the same line or same equation. It's the same exact equation. Down below, you've got some words. It says that systems can be classified by the number of solutions. So there's some words that we call these. When you have at least one solution, you are called consistent. If you have no solutions, you are inconsistent. So you just add an IN on the front. When you have exactly one solution, so you got two different lines and you get exactly one solution, those lines, they are independent of each other. So we would say if you have exactly one solution, you're independent. If you have infinitely many solutions, that means you are the same line. You are dependent. So we're going to go and we're also going to describe these situations with those new words. So if you have at least one solution, so this very first column, you have one solution. So what is a word that we could use to describe it here? Consistent. Is there another one? Yep, both of those words were consistent, independent. Good job. What about parallel lines? How could we call those? What could we call them? Inconsistent, and that's really it. What about infinitely many solutions? What could we call it? Dependent. What else? Consistent. Yeah, there's at least a solution, so it is consistent and it's also dependent. Dependent. Does everybody have that stuff written down? What we're going to do now is we're going to go on to the next section. And on the next section, we're just graphing lines. We're seeing if they cross. If they cross, that's your answer. So that's why we did that graphing stuff last class. I hope everybody checked yourself. For these, we're going to graph them. So you got two lines, we're going to graph them. The first one we're going to graph, y is equal to 2x plus 1. So this should be a review, 2x plus 1. So I'm going to go up to 1, and I'm going to put a point. And then I'm going to go up 2 and over 2 and put another point, put a few more points. And I'm going to connect the dots. Now I'm going to graph the other line. The other line says that I go up 8. What does it say? Minus 8. I go down 8. Oh, that's off the grid. Well, I'm going to say that minus 8 is right here at this point. That's where I'm going to put my dot. And then it says that I would go down 5 and then over 2. Well, I'm going to use symmetry to go up 5 and then to the left 2. I'm also going to connect the dots. Do the lines cross? Can you see where? Yep. So what we're going to do is we're going to identify that spot. And then it says that we need to write, well, actually I didn't put a spot, but we're going to write down what the solution is. And we're going to write it down two ways. So the first way that we're going to write it down is as a point. And so that point, what is it? A point has two parts. A point is going to have an x, comma, y. -2, -3. So we're going to say that that solution is -2, -3. The other way we're going to write it, because sometimes you have a question, and it's going to say, what is the y value of the solution? So we're also going to say, it means the same thing as x is equal to -2, y is equal to -3. I want you to write these all the ways. So I want you to know that they mean the same thing. We good with that? It's not so bad. You're going to graph lines. You're going to see if they cross. Let's do example 2. So example 2. Ooh, that one doesn't look fun to graph. So let's start with this one. Let's graph the second one first. So this one, let's start with 2. So we got to go up 2, put a point. Then the slope says up 2 and over 5. Also going to go down 2 and over 5. So we just graphed the bottom one. For the top one, we're going to have to do a little bit of math magic first. So what we're starting out with, and I'll do this one kind of off to the side. I have 5y is equal to 2x plus 10. What we want is a y equals equation. To get y by itself, can't we just divide it? Oh, man. Sorry, y'all can't see that. That's not what I meant to do. There. What I need is to get the y by itself. To get the y by itself, one thing that I can do is I can take and divide by 5. Divide by 5. So I get y is equal to 2/5 x plus 10 divided by 5, or 2. When I go to graph this one, what happens? Anybody? What happens? Yeah, it's actually the same line. I go to plot that point, and then I go up 2 and over 5, down 2 over 5. It's actually the same line. Usually to show it's the same line, you kind of go a little bit further on one of them, so it looks like you've got 2 sets of arrows. So for this one, there is infinitely many solutions. Anytime this happens, I want you to tell me why you're answering that. You're answering that because you can say that they're the same line. So anytime you get infinitely many solutions, I want you to tell me why. We good? For this one, the top one doesn't look fun, so I'm going to start out with the bottom one. And that's what I want you to do too. Even if you suck at rearranging these to graph them, I don't want you to get no points if you're like, oh, I don't know how to graph the first one, so I'm not going to graph it. Don't do that. At least graph one of them. Get some points. So for this one, I'll graph the bottom one first because it looks easier. So I'm going to go down to -5, and I'm going to put a point. And then it says I'm going to go up 3 and over 2. I'm going to continue that on. Then I will connect the dots. For the top one, it's the same method that you're going to do. You're going to take and divide by 4, divide by 4. So I get y is equal to negative, let's see, 6/4, that can reduce. What can it reduce to? Oh, divide by -4. I didn't put -4. -6 divided by -4, that's going to be a positive. And 6/4, that reduces, doesn't it? 3/2, so positive 3/2x. And then 28 divided by -4. It's going to be a negative. What's 28 divided by 4? Y'all got to brush up on your math facts before the test. 7. All right, let's go plot that one. 7 is at the very bottom. Okay, and then I'm going to go up 3 and then over 2. Up 3 over 2. What's happening? Did your lines cross? Just because they don't cross in the picture, you've got to ask yourself, will they cross somewhere? If they kept on going, are they going to cross at some time or somewhere? You think so? Where are they going to cross at? You think they're going to cross over here? Why? So this one's going to keep going up 3 over 2, up 3 over 2. This one's going to keep going up 3 over 2, up 3 over 2. So do you still think they're going to cross? No. Why are they never going to cross? They have the same slope. Yes. So for this one, you would say no solution. And you're not just going to put no solution. You're going to tell me why is there no solution? You got to know why there's no solution. So you could either say because they're parallel. You could also say because it's the same slope. Any of those would be okay with me. Bless you. So I want to make sure that you give me all of those things. You got to know why it's no solution. For the next one, y is equal to -1. Y is equal to -1. Okay, there's no x there, so I'm not going to have any kind of tilted line. It's either going to be my horizontal or my vertical line. Okay, well, if it says y is equal to -1, I got to go down to -1 and put a point. And that means I got to cross through or chop through the y-axis. So that's going to make me a horizontal line. Okay, the next one. All right, the next one is not y equals form, so I got to fix it. It's almost y equals form, but I need to subtract 6x on this side. So if you want to rewrite it, that's fine. Y is equal to, I can switch those places, -6x minus 7. So I can switch the -6 and the -7. So to graph this one, I got to go down to -7, which is the very last, the last line there. And then it says I'm going to go down 6 and over 1. You can put over 1 if you need to. Well, I've run out of graph. That ain't happening. So I can also go up 6 and to the left 1. Why is what negative? Because over here, I need it to be y equals form so I can graph it. And so to have it as y equals form, I've got +6 over here, so I could subtract 6x to that side. Good question. So I can connect these dots. Do the lines cross? Yes. And this is what happens more often than not. I only had 4 examples I wanted to show you. So of course I wanted to show you infinitely many. I wanted to show you parallel, but that's not what happens the most. So yes, I do cross. That's where I cross. So I'm going to say where I cross at, what's that point? -1, -1. So I'm also going to write down x is equal to -1, y is equal to -1. I want you to be very familiar with all 3 ways to write it, or all parts of the solution. We're actually going to stop there. We've got the back that we're going to do, but that means that you still need to do your assignment. On your assignment, the front half is what we just did. The back half is what we didn't do. So you are charged with doing the front half for homework, and then we're going to finish up the back. If you're brave and you use a pencil, try the back side of the notes.